Types of piles. End-bearing piles rest on solid strata. Load is directly transferred. Friction piles rely on skin friction with surrounding soil. Bored piles. Holes are drilled then filled with concrete. Driven piles. Precast piles driven into the ground. Bipier caisson foundation, large diameter cylindrical foundations. Constructed by drilling holes, placing reinforcement, and pouring concrete, used for heavy buildings, bridges, and waterfront structures. 4. Factors affecting foundation design. The selection of foundation type depends on several engineering and environmental factors. Key considerations: factor impact, soil type, clay, sand, rock, or loam affect bearing capacity and drainage. Soil bearing capacity determines how much load soil can support safely. Water table level. High water levels require waterproofing and drainage. Frost depth. Foundations must be below frost line to avoid heaving. Building load. Heavier structures need deeper or more reinforced foundations. Site conditions. Sloped or narrow sites affect excavation and design. Nearby structures can limit space or create shared foundation needs. Budget and timeline. Raft foundations may cost more. Piles need special equipment. 5. Construction process of a foundation. Step by step. Site clearing and surveying. Remove vegetation, debris, and mark boundaries. Soil testing. Geotechnical survey. Determine soil type, bearing capacity, groundwater level. Excavation. Dig to the depth and shape required based on drawings. Formwork setup. Wooden or metal molds to shape concrete footings. Reinforcement placement. Place steel rebars according to structural design. Pouring concrete. Concrete mix poured into forms, vibrated to remove air pockets. Curing. Concrete kept moist for several days to gain strength. Damp proofing and waterproofing. Apply bitumen or membranes to resist water. Backfilling. Fill excavated areas with soil or gravel, compact in layers. Foundation inspection. Performed by engineers or city authorities before construction proceeds. 6. Common foundation problems. Differential settlement. Uneven sinking. Leads to cracks. Water seepage. Caused by poor waterproofing or drainage. Poor compaction. Leads to instability, undersized footings. Structural failure. Tree roots or expansive soils can cause uplift or cracking. 7. Foundation in modern construction. BIM. Software perspective. If you're using software like ArchiCAD, Revit, or SketchUp, here's what entails the foundation modeling process. Foundation slabs. Modeled using slab tool or morph tool in ArchiCAD. Footings. Custom profiles or object libraries for pad or strip footings. Rebar detailing. Available through plugins or Revit Structure for BIM detailing. Section cuts. Show footing depth, reinforcement, waterproofing layers. Schedules. Auto-generate quantities of concrete, steel, or waterproofing. Tags and labels. Add notes for footing sizes, depths, materials.